We have studied the properties of system. We have a system and we have studied different properties of system. In our last video, we have seen what is a memoryless system, what is the meaning of invertibility. Then we saw what is a causal system. We saw what is a linear system. We saw what is time invariance. So we have seen the basic and some other topics also, other properties also. We have seen these properties in detail in our last video. Now let's see how we find out whether a system is memoryless or invertible or linear or time invariant. So in this video, what we'll do, we'll have a small recap of the property and then we'll solve some problems so that this is very clear to us. Just looking at the expression of the system, we know how we write the expression. If this is xt and this is yt, so this is for a particular input, we have a particular output. So if this xt is given and this y, the relation between y and x is given, how we can understand whether the system is memoryless or invertible or linear or time invariant? So the first property is memory of a system. What is memory? If output at any moment is dependent on the input at that moment only and it is not dependent on the previous values of the input, then it is said to be a memoryless system. That is, if we have yt that is dependent on xt only, it can be 2xt plus, let's say, xt square, so that if your input is at t equal, let's say this is your t and this is t, I've used the term t only. So if this is the system and we have certain value and y is dependent on this value only, it is not dependent on xt minus t0. So about this, let's say this was at t and this is at t minus t0, let there be some value. It is not dependent on this value, it is dependent on the value of x at t only. This is a system that is memoryless. In discrete, this was for continuous system. If we talk of discrete system, let's say at n, this is n and the value here is xn. So if the output is dependent on this value only, that is, let's say this is 31 xn plus x square n, it is dependent on the value of the input at n only, not at any other value, previous value. So this is called a memoryless system. Clear? But if yn is equal to xn plus xn minus 1, then this is, let's say this is xn minus 1. So it is dependent on the value of this and this also, that is previous value also. So this is not memoryless, but this is memoryless. Okay. The second property is invertibility. If distinct input gives distinct output, see, second property is invertibility. If distinct input gives distinct output, you should remember these statements. Distinct input gives distinct output. Meaning is, if you give x1t, it gives y1t. But if you give x2t, it will give another output, let's say y2t. For both x1t and x2t, the output cannot be y1t. This is the meaning. So this is the conceptual meaning of invertibility. So if the system is invertible, then we have an inverse system. And what is this system? Inverse system, which I'll explain by diagram. Let's say this is our system S. It takes xt and it gives yt. Now we can have an inverse system which takes yt and gives xt. So this is the meaning of inverse of the system. Input to this is output to this, and when we put output, it gives this particular input. That is, this input gives this output, this input gives this output. These two are distinct. So if the system is invertible, we can design an inverse system which will take the output of this system 1 and will give the input of system 1. So this is one system, this is a second system. Clear? Now let's see an example and understand how we, what is our approach when we are faced with a problem. We have a system, yes. This is the input, this is the output. Output is given as, this is a discrete system undoubtedly, it is given as xn into xn minus 2. The first subpart of this question is it memoryless? If this system is memoryless. Now see, yn is xn minus 2. Let's say this is our input pulse wave. Let this be n minus 2, this be n. Okay. So you can take 0 and minus 2. So this is the first value, this is at xn minus 2 and this is xn, the value at xn. The output is dependent on this value and this value, product of these two values. This is a previous value, not the current value. Xn means at n equal to 0, the value at n equal to 0. But this is at n equal to minus 2 also. So the product of this with previous. Undoubtedly, it needs memory. So the system is not memoryless. Okay. First part is very clear. You can just look at this part and understand that this is not memoryless. Second part. It says determine the output when input is, your input is a, this is impulse function, where a is a complex constant, complex or real constant. So this is a constant. What will be the output? Okay, let's see what is the output. Yn will be xn. So in place of xn, we'll write this into xn minus 2. So again a into n minus 2. So the value is a square del n minus 2. But try to understand this. What is the meaning of this? See, at n equal to 0, you have this value, this impulse, unit impulse. This is n minus 2. So at minus 2, this. So that point to understand is that at n equal to 0, this del n is 1 and everything is 0. So at n equal to 0, this will be n, this will be 0, and at n equal to 2, it should be to this side. Actually, this is n minus 2, so the shifted impulse has to be to this side. So at n equal to 2, this del n minus 2 will be 1, this will be 1, and all inputs will be 0. So at n equal to 0, this is 1 but this is 0, and at n equal to 2, this is 1 but this is 0. So the output is always 0. Other than 0 and 2, these two both are 0. So yn is 0. At n equal to 0, this is 1 but this is 0, so again 0. N equal to 2, this is 0. Sorry, this is 1, this is 0, again 0. So this value is effectively 0. For all values of n, this yn will be 0. So we had to determine yn. Yn is this. Clear? Third part. Is the system invertible? Now we'll see third part. We have solved second, now third part. I told you invertibility means for distinct input, the output should be distinct. But here, whatever input you put, the output will be 0 only. In this case, you keep changing the input, the output will be 0 only. So this is not invertible because for distinct inputs, we are not getting distinct outputs. Clear? Next, let's see the property causal. What is a causal system? This property means that the system output is dependent on the value of the present input and the values of the past. Memoryless means it depends on the value of the present only. That is, let's say this is our, let's take xt, this is your xt, okay, at t equal to t1, let's say the value is xt1. So a memoryless system means when you are talking of x at t1, the output is dependent only on xt1, not any other value. But in case of causal system, this is for memoryless system. But when you talk of causal system, the output at t1 will depend on xt1 and xt, where t is less than t1. That is, it depends on these values, or it may depend at, let's say, t1 minus 2, t1 minus 4. So if it depends on previous values also, if the output depends on present and previous values also, that system is called causal. So by definition only you can understand that all memoryless systems are causal because they depend on present value of the input. And causal, I am not saying that it has to depend on previous values also. It says on present value, that is memoryless system, and also on the past values. So this is and this, not necessary. So memoryless systems are causal, and additionally if it depends on previous values also, that is also causal. That is, the system is not anticipative, it is non-anticipative. That is, it does not anticipate the values of the future. That is, if t2 is greater than t1, then a causal system, this will not depend on x at t2. It will always depend on this value and values before it, not after this. That is, it does not anticipate the future. This is the meaning of causal system. Okay, let's see an example so that this is clear to us. See, let's say y is x of sine t. Now we have to find whether it is causal or not. Okay, let's see the values at 2-3 points at t equal to 0. T equal to 0, your y0 will be x sine of 0. That is, sine 0 is 0. That is, y0 is equal to x0. That is the value of x at 0. Correct? So this is causal at up to this point. Now let's see at t equal to minus pi by 2. So at minus pi by 2, the value will be x sine minus pi by 2. What is minus pi by 2? Sine of minus pi by 2 is minus 1. So this is x minus 1. Now see, pi is 3 point something. So if you take this 0, this minus 1, so pi by 2 will be somewhere here left to this. That is, your value of the output will depend on future. We are not talking of x at this point. If this was our graph, we are not talking of x at this point. We are talking of x at minus 1. That is some future value. Obviously, this is not causal. This is the definition itself says that it should depend on the present and past values only. But this is anticipating the future. Also, you can take another value also. See, at minus pi, somewhere, let's say here is your minus pi, 3.14. Let's see, y depends on minus pi only or not. For this, we'll have minus pi, that is x of sine minus pi. What is it? It is 0. So this is x0. Now, the output value for this anticipates the value at 0. Pi distance away from this point. So it is again anticipative. Therefore, a system, if we have a system which is actually this, then it is not causal. Clear? There is a property which is called stability. By stability we mean the system should be stable. That is, if we have input is x and we have a small change in the input, that should result in a very small change in output. It should not be very big. That is, if the input changes by 1%, the output should change by 1 or 2% or less than that. It should not change by 200%. This is the meaning of stability. Okay. So system is stable if small inputs in small changes in input lead to very small changes in output. The output should not diverge. One of the most important property of a system is time invariance. You must understand it very properly. What is time invariance? First of all, understand the conceptual meaning of this. Conceptual meaning means that the properties and characteristics of a system should not change with time. Let's understand it. Let's say we have this R, this is V, a voltage source. Let's say this is I. What is I? I is V by R. Now, if the resistance, the quality of the material of this resistance is not up to the mark, and let's say after few hours, after after connecting into this circuit, after some time, this changes by this R becomes 2R. The resistance increases because of heat or whatever method, this increases. Then your new current will be V by 2R. That is half of the original I. So the characteristic of the system has changed. So that is not a time invariant system. It varies with time. This is the conceptual meaning of time invariance. But in signals and systems, we are studying signals and systems. In signals and system, we have a different definition of time invariance. It means if there is a shift in input, time shift in input, that should result in the same time shift in the output. The meaning is, if we have for xt, if the output is yt, then if we shift this by 0, this should also shift by this only. In terms of discrete system, if xn has an output yn, then x n minus n0 should correspond to y n minus n0. Very clear? An equal shift in time, if there is t0 shift in input, there should be t0 shift in output. That is, if this is the curve, we are talking of, this is xt curve and this is yt curve. The output is like this. So when we talk of t equal to 0, output should also be giving the value of this only. But if we are talking of t at t0, then the output should be t at t0. There should be equal shift. This is the meaning of time invariance. Let's see some examples and understand what is the meaning of time invariance. Let's talk of a sine function. Our question is, why is sine of xt is such a system? That is, if it is a system, this is your xt and this is yt, this is your system. Is such a system time invariant? This is the question. Let's see. Let's say we have x1t as output, that results in y1t output. So this will be sine x1t. Okay, clear? Let's say we talk of another signal x2t, which is actually x1t minus t0. Okay, then y2t, what will be y2t? Y2t will be given as sine x2t, and x2t is basically this, that is sine x1 t minus t0. So you see that this shift gives output also as this. You can see. So the output is, if we change the input by t minus t0, the output will be sine x1 t minus t0. This take it as 1. If from direct definition we put, this is t actually, so if we put t minus t0 in place of t, what we will get? Sine x t minus t0. Okay, x1 is about this. So if we talk of putting x1 was just for our explanation. We can take directly x also. So for us directly from the system, if you put, let's say, understand it like this. Let's drop x1, x2. Let's say this is the system. What will be yt minus t0? Directly from the definition of the system, it will be sine x t minus t0. Okay, let it be 1. And what we do, we know that when the output is xt, now what we'll do, this is direct definition. Now from the input side, we'll see what is the output. So for xt, it is yt. So in place of xt, if we put another signal, let's say x1t, it will be y1t, that is yt is sine xt, this is sine x1t. Clear? This is one signal. What if x1t is basically xt minus t0? If the input is this, then what will be the output? The output will be sine of xt minus t0. This is exactly equal to 1. Therefore, if we have a time shift in the input, there is an equal time shift in the output. Therefore, this system is time invariant. Clear? Now, understand it more properly by this example, the second example. I am giving you another example. Our yn is n into xn. Okay. So from first definition, we know if we take yn minus n0, it should give what? In place of n, we will put n minus n0 and then xn minus n0. Okay, this is from the very expression, first expression, basic definition. Now let's take it differently. Let's take x1n as the input. What will be your output? Your output will be n into x1n. Any doubt? No. x2n, another input. This will give n into x2n. Now, if your x2n is nothing but xn minus n0, this is this, then what will be the value? This is n and this will be xn minus n0. That is, in this case, your output will be n into x into n minus n0, not n minus n0 into this. And these two are, this is y2n against n to the power. This is what? Yn minus n0 only. We are talking of this only. So this is the value when the output has been shifted to n minus n0. When output has been shifted to n minus n0, that is, see, we are talking of n minus n0. This is the input. So when we shift it to this, we have output, that is this one, n into x n minus n0. This is your output. But as per the definition, this is this. So these two are not equal. 1 is not equal to 2. Therefore, the system is not time invariant. A change will not give the same output as desired. The system is not time invariant. Okay. Yt is equal to x2t. You know, this is compressed by a factor of 2. So let's take x1, x1t. Okay, we take example of x1t, which is like this, from minus 2 to 2 value. This is your x1t. Okay, what will be y1t as per this? This will be a compressed version of this. You know this. Your y1t will be compressed version. That is, this will be from minus 1 to 1. Okay, from here we have this. Now second, let's take x2t, which is basically x1 t1 minus 2. We have another input which is x1 t minus 2. What is the meaning of x1 t minus 2? This is your x1. So t minus 2 means shifting it to this side, that is, this will go to 0 to 4. This is your x1 t minus 2. What will be output because of this? It will simply get compressed by factor of 2. Okay, so your y1 t is this. If you take direct value y1 t minus 2, this is your y1 t minus 2, what you will get? This will go to this point, that is minus 1 plus 2. So this will go to 1 and then 1 plus 2, 3. So this is your y1 t minus 2. See, this picture and this picture, these two are not equal. That is, this is direct from the system expression, and this is when we have altered the input. These two are not equal. Therefore, the system is not time invariant. Okay. We saw the property of time invariance, very important property. The next very important topic is linearity. This is another very important linearity. This is another very important, and I should say linearity and time invariance. These two are the most important properties of a system. What is the meaning of linearity? A system is said to be linear if it possesses two properties. First property is called additive property, and second property is called scaling or homogeneity. Okay, so what are these properties that we must understand? Linearity means if the input is x1t, for an input equal to x1t, if the output is y1t in continuous time, and in discrete time, if to an input x1n, we get y1n, and for another input x2t giving output y2t, here x2n should give, or if it gives y2n, then additive property means if the input is x1t plus x2t, this plus this, then the output should be y1t plus y2t in continuous time. This is linear additive property of linearity. Here, if the input is x1n plus x2n, then your output should be y1n plus y2n. Clear? This is called the additive property. This is the first property of linearity. Second property is scaling. It means if for x1t we have y1t, then for a into x1t we should have a into y1t, or a into x2t should give a into y2t. Similarly, in discrete time, a x1n should give a y1n. A is a constant, real or complex. So this is second property, which is called scaling or homogeneity. This constant actually scales the input. See, it was x1, so now it is ax1. So if a system possesses these two properties, the system is said to be linear. Clear? And from these two properties, we come to a conclusion that if we give input like this, a x1 t plus b x2t, that is, we have used additive as well as scaling property, then the output should be a y1t plus b y2t. Similarly, a x1n plus a b x2n should give a y1n plus b y2n. This property is called principle of superposition. Okay, so this is also a very important property. Let's see some questions and understand this property. A very familiar example. I have used it in the last video also. Let's understand it again. Solving same problem or looking at the same solution again and again will give you, in every time you will look at it, you'll have a new insight into it. So if your yt is txt, is the system linear? So how we'll check? We'll use the two properties. See, the way the approach is, let's say for x1t, what we get? We get y1, which is equal to t into x1t. Okay. Then let's change the output to x2t. So y2t will be t into x2t. Now, to check additive property, if a into x1t we apply, this will be simply a into t into x1t. So, scaling property is there. Let's see additive property. So, if we add x1t and x2t, if this is the input, what will be output? The output, if let's say this is x3t, x1t plus x2t, then this y3t will be what? It will be t into x3t simply. But x3t is what? This x1t plus x2t. That is, if you expand it, this is t x1t plus t x2t. This is what? This is y1t and this is y2t. So this satisfies the additive property. And you can see if this was a x1t, the output would have been a t x1t. So that if instead of this we use x3 like this, a x1t plus b x2t, if this is your x3t, then output, the third output will be y3t will be what? It will simply be t into x3t, and you know what is your x3t? This is t into a x1t plus b x2t. Just expand it, it will be a t x1t plus b t x2t. This is what? This is a y1t plus this is b y2t. So it satisfies the second principle also. So this is superposition. We can see the additive as well as the scaling property is satisfied. Therefore, this system is linear. Okay. Now let our question be like this: if yt is equal to x square t, then is it linear? Now let's see. We know y1t, if this is x1t, your y1t will be equal to x1 square t, and for x2t this will be x2 square t. Okay. Now if my input is x3t, which is basically a x1, we will now directly use scaling as well as additive property. We will directly check both properties. This is the way we actually solve problems. The first problem I expanded so that you understand it properly. Now we'll use this. So if we use x3t, output will be x3 square t. What is the square of this? This will be a square x1 square t plus b square x2 square t plus 2ab x1 t x2 t. See, is it same? If we had taken this value, what we should have got? We should have got a y1t plus b y2t, but y1t is this. So, and what we are getting is this. This is a into y1t, because if this was a x1, this would have been a x1 square t. If this were b x2t, this was b x2 square t. So this is a y1t plus b y2t plus this. So this is not same as we want. This is not equal to a y1t plus b y2t. Therefore, the system is not linear. Okay. Let's see one more example, very interesting example, and then we'll solve more complex problems. One more simple example, but very interesting. Yn is equal to 2xn plus 3. Is the system linear? Now, just looking at it, the very obvious observation that we can make is the system seems to be linear. Let's try out. If our input is x1n, output will be y1n will be 2x1n plus 3. Okay. If it is x2n, your y2n will be 2x2n plus 3. Very simple. What is the output if my input is x3n, a x1n plus b x2n. By putting this input, we can check both scaling as well as additive property. So for x3n, our output will be twice x3n plus 3. What we want? This should be equal to a y1n plus b y2n, so that the system is linear. Let's see if we put the value of this. So what you will get? You will get 2ax1n plus 2bx2n plus 3. Okay, putting this value in this. So you can do one thing. You can take ax1n. Let's put 3. So we have 3a, we'll put minus 3a. Then we can take b out, 2x2. What we have taken out? We have taken 2 out, sorry. We have taken a out. So this is 2x1n plus 3. So we'll do minus 3a, so that this remains 2a x1n. Similarly, this is this plus 3 minus 3b, and then we have this 3. This is what? This is your y1. So this is a y1n. This is, we wanted this result. Similarly, this is b y2n. But, and this is the desired result. For this input, the output should be this. Then we say system is linear. But we have this noise also, plus 3 minus 3a minus 3b. This is redundant. This is a redundant value. Therefore, the system is not linear. So don't get confused. Don't just look at the expression and say, oh, this is linear system. This is linear, so the system is linear. It may or may not be linear. Clear? Yt is equal to t square x t minus 1. Let's see whether the system is linear or not linear, and let's see whether the system is time invariant or not. First, we'll check for linearity. Let's say for x1t, our y1t will be t square x1 t minus 1. Simple. For x2t, your y2t will be t square x2 t minus 1. Very simple. What it will be for x3t? It will be t square x3 t minus 1. Very simple. Now what if your x3t is a x1t plus b x2t? We are checking both scaling as well as additive property. So this will be t square x3 of t minus 1. x3 of t minus 1 means just a x1 t minus 1 plus b x2 t minus 1. What is this? This will be a t square x1 t minus 1 plus b t square x2 t minus 1. What is this? It is y1t. So this is a y1t plus b y2t. Therefore, this input, two inputs added, scaled, gives the corresponding output. Therefore, the system is linear. So we have seen that the system is linear. Looking at this, this was a square. So first thing that would come to your mind that the system must not be linear. But see, the system is linear. Now, second thing, we'll see whether the system is time invariant or not. Okay, looking at this, if we talk of t minus t0 from the expression, the output will be t minus t0 square x t minus t0 minus 1. So this is what we get the output from the system. If we put input this, then this, okay, directly from the expression. Now let's take from input side. What is the output if this is this? For x1t, what we get? We get y1t, which is equal to t square x1 t minus 1. Okay. Now let's say x2t. Undoubtedly, y2t will be t square x2 t minus 1. What if x2t is basically shifted version of this? What will be the value? If this is this will be x2t is x1t minus t0. So this will be t0 and x2t minus t minus 1 means x1t minus t0 minus 1. Okay, so this is t square this. But this is not equal to this. See, as per this should have been t minus t0 square. So this is not equal to, if you see from direct definition, this is not equal to this. Therefore, the system is not time invariant. Okay. Yn given by x square n minus 2. Okay, this is your system. Is it linear? Is it time invariant? First, x1n will give output y1n, that will be equal to x1 square n minus 2. Okay. Similarly, x2n will give y2n, that is x2 square n minus 2. Clear? What if we give this input, let's say x3n? It will give y3n, that is x3 square n minus 2. But what if your x3n, as we do for checking linearity, what if this is ax1n plus bx2n? This will be this, that is the square of this. This will be a square x1 square n, say minus 2, plus b square x2 square n minus 2 plus 2ab x1 n minus 2 into x2 n minus 2. Now this is not equal to a y1n plus b y2n. Therefore, the system is not linear. We had seen this for x squared t also in continuous time domain. Now let's see whether the system is time invariant. Okay. For x1n, it is this. For x2n, this is this. Now, what if your x2n is basically x n minus n0? What will be the value? Then your y2n for this will be x square n minus 2. So this will n, this means this minus 2. Okay. So this is the value, first value. And directly from here, if you take for n minus n0, what you have? You have x square n minus n0 minus 2. So these two values are equal. Therefore, the system is time invariant. That is, if you shift the input by certain time, the output will be shifted by that time only, invariant. Let's analyze another system where the output is given as xn plus 1 minus x n minus 1. Let's see what properties does it possesses. Is it memoryless? No. It depends on certain previous value. So it is not memoryless first. Is it causal? No. It anticipates the future value of the input. So it is not causal. Okay. Is it invertible? See, for distinct values of n, we will have distinct values of the output. Therefore, this is invertible. And so you can design an inverse system. Next, let's see. Is it linear or not? We will start with our known approach. This gives y1n, which is equal to x1 n plus 1 minus x1 n minus 1. Okay. x2n gives y2n, which is x2n plus 1 minus x2 n minus 1. So x3n will give y3n, that is x3n plus 1 minus x3n minus 1. Now what if our x3n is equal to a x1n plus bx2n. This is what we have to see. So this is x3n plus 1. So this will be a x1n plus 1, x3n plus 1. So a x1n plus 1 plus b x2n plus 1. This is from this. From this it will be a x1n minus 1 again minus b x2n minus 1. Okay, this is what we get. Now this minus this, see this and this is actually a y1n, and this is b y2n. So the system is linear. Okay, now let's see whether the system is time invariant. Okay, system is linear. Now x1n gives y1n, that is equal to x1n plus 1 minus x1n minus 1. Okay, similarly x2n gives y2n, which is x2n plus 1 minus x2n minus 1. Okay, now what if your x2n is actually equal to xn minus 0, a shifted version of the input signal? This will give, that is y for n minus n0, this will give, this is this. So what do we get? We get this as our output is x2n plus 1. So this will be xn minus n0 plus 1, and this is xn minus n0 minus 1. Okay, here we get this. And if we put from direct definition, what we'll get? Same thing, x n minus n0 plus 1 minus x n minus n0 minus 1. Therefore, since these two are same, the system is time invariant. Clear? Very good question. It says a continuous time linear system has this output. When the input is ej2t, when it passes through the system, the output is ej3t. When the input is e minus j2t, when it passes through the system, the output is e to the power minus j3t. This is a linear system. We have to find the value of the output when the input is cos 2t and when the input is cos 2t minus half. See, it says this is a continuous time linear system. If this is a linear system, it will have this property, superposition, that is for a x1n plus b x2n, the output has to be a y1n plus b y2n, and for continuous time system also this is the superposition principle. So when it says the input is, let's say this is your input, this is system, this is your output yt. So when the input is e to the power j2t, the output is e to the power j3t, so that if multiplied by a factor half, the output will be this, a into xt is a into yt. Similarly, e to the power, the second value, see, minus j2t gives e to the power minus j3t. So if you multiply it by half, this will be this. Now additive property has to be there. So if you add this and this, the output will be this plus this, that is this plus this. What is the value of input? This plus this, that is half e to the power j2t plus e to the power minus j2t. This will be the input. What is e j theta? It is cos theta plus j sin theta, and in case of minus j, it is cos theta minus j sin theta, so that e j2t plus e j minus 2t, this is simply cos 2t. This we have to find, the first problem. So if we add these two, what we'll get? We'll get cos 2t, that is this plus this. If this is a, this is b, so this is a plus b. Output will be this plus this, half e j3t plus e minus j3t. Again, what is this? This is equal to cos 3t. So if the input is cos 2t, the output will be cos 3t. Okay. Now Now let's see the second part. Similar to what we just saw, cos 2t minus, let's analyze this, 2t minus half. This is cos 2t minus 1. We can write it like this, half e to the power, what will be e to the power? This is your theta. So j 2t minus 1, okay, plus e minus j 2t minus 1. This you can express it like this, or you can write it like half e minus j into e to the power j 2t. Here we have plus j, that is e to the power j, then e to the power minus j 2t. Okay, but this is also scaling. This is a number. So if e to the power j 2t gives e to the power j 3t, then multiplying by this e minus j by half, e minus j by half will give e minus j by half. Similarly, e to the power minus j 2t gives e to the power minus j 3t. So multiply by e to the power j by 2 will give e to the power j by 2. Okay. So when we add these two, we get this value. Okay. This we have seen. So this gives basically cos 2t minus half. That is this plus this. So the output will be this plus this. That is half e to the power minus j e j 3t. That is we can write e to the power j 3t minus 1 and plus, see here again, minus j 3t minus 1. We can write it like this, half. So this is cos of 3t minus 1. So if the input is this, the output will be cos 3t minus 1. Okay.